My name is Grace Yu. I am a sophomore student at Rensselaer Polytechnic Institute, and I'm studying aeronautical engineering and mechanical engineering.
Yep, my name is Ammar Barbee. I am a senior mechanical engineer, also at Rensselaer Polytechnic Institute. I guess this actually came from, I'm currently taking a class called Inventor Studio 3, right, which is a sequence of courses taught at RPI that's really all about fostering sort of innovative thinking over sort of the traditional design thinking pathway. That's sort of the typical pathway that most engineers are taught. And this project came about, we were given the constraint in the class to think about novel ways of designs for steam power plants. So in this case, we sort of went a little bit above and beyond for the class in designing this more high-level scope project, right? Not only focusing on steam turbine, but actually how you could do desalination with a steam turbine. And then independent of what was required, I mean, the class deliverables was a little project. So discovering, right, the SME competition, right, assembled a team, right? I'm sort of the chapter president. So I just decided to assemble a team outside the class and take the project, right, and apply it to this competition.
Probably time, partially.
Yeah,
we're all very, involved people with other things at school or involved in research and think we had a pretty tight deadline, and I remember you spent a lot of time, stayed up a little bit and tried to get everything done, make sure it was perfect.
Yeah, I mean, because of the scope of what we decided to take on, right, as like the entire project, it became a very interesting balance on, right, as engineers, it's like we're fascinated with diving into the details, right, and figuring out each little nuance. And for us, when we're designing this entire plant as a system, right, and also looking at the careful areas with additive manufacturing, right, it became a very difficult decision to sort of figure out what to prioritize, what detail to go to what extent, right, while staying true to sort of what was required, for the competition.
Part of it, I think, comes from research. We're both part of Center for Automation Technologies and System, CATS, at RPI, and we both do manufacturing-related research. A lot of it involves additive manufacturing and trying to combine different elements of automation together. So that's part of why we're interested in digital manufacturing.
Yeah, and I think, like, for me, even before coming to RPI and getting involved with research, I did first robotics. But that's really where I got my hands dirty, running CNC machines, learning how to program them and write G code. And that propelled, right, my passion for manufacturing. And sort of with doing research and other co-ops and internships, right, that sort of has allowed me to sort of really have a passion for digital manufacturing.
I think as the industry advances, we're looking at more and more robotics and automation-based systems. It's really important to have an understanding of how to design for manufacturing and how to actually design, how to actually make things, and then that helps you in turn to understand things. So I am a control systems engineer by trade, and I would, for automation stuff or robotic stuff, I really think learning from how to manufacture stuff from this challenge, researching everything, it'll help me to understand how to actually make these robots work for the engineers in the field in the future.
Yeah, and I think specifically in context of our project, right, where really when we started diving into the analytical study, right, doing feasibility calculations, we had to do a lot of like thermodynamics, heat transfer, right, things I at least learned, right, as a mechanical engineer, that has almost nothing to do with sort of analyzing manufacturing processes. But I think what became an interesting aspect of that fundamental training is how balancing sort of the knowledge that you gain in a mechanical engineering education with that of like a manufacturing background and figuring out, right, okay, the balance. In our case, it's figuring out where to sort of choose the specific, say, materials, right, that are attuned to additive processes, but that are also ideal for, in our case, right, like the actual operations of the plant in our sort of an analytical models. So
I think it was a great experience to kind of combine what we learned in the classroom to something we can actually apply in real life and just combine that experience together and
exactly.
make something out of it.